Okay, so lines cut by transversal. A transversal is basically an intersecting line which cuts through a system of lines. In this instance, our transversal is the red line, which intersects these two parallel lines. So that is a transversal. These transversals create different types of angles, and we're going to look at those different types of angles that we have in geometry. So whenever we have a transversal, in this instance, we have our transversal P, what we get is different types of angles, and the first type is interior angles. Interior angles are basically angles on the inside. So these angles on the inside of those parallel lines, all those angles would be interior angles. Exterior angles, on the other hand, are angles on the outside. So they're going to be everything outside of those parallel lines. Other pairs of exterior angles include these right here, but those just aren't marked in this example. But all of those are exterior angles. Think of exterior of a house, exterior angles. Think of interior of a house, interior angles. So interior on the inside, exterior on the outside. We also get what are known as vertical angles. Vertical angles are basically opposite angles, so angles which are opposite of each other. A unique thing about vertical angles is they are congruent to each other. So if we have vertical angle pairs, and those are congruent to each other. So in this instance, this angle and this angle would be congruent to each other, and this angle and this angle would be congruent to each other. So vertical angle is another type of angle we see in geometry. Next thing we have is corresponding angles. Again, we have a line that cuts a pair of parallel lines. Line L and M in this instance are parallel, and N is our transversal. Corresponding angles are angles on matching corners. So A and B are on matching corners, so those are corresponding angles. This angle and this angle are on matching corners, so those are corresponding angles. So here we have pairs of angles, pairs of vertical angles, pair of corresponding angles. This angle and this angle are matching corners, so those are corresponding angles. And lastly, this angle and this angle are on matching corners, so those are corresponding angles. So basically, whenever we think of corresponding angles, they need to correspond to the side that they are in relation to those parallel lines. So this one is on the far left, so this corresponding angle pair would be this one, this one, this one would be this one, and then A. So corresponding angles, angles in matching corners. We also have alternate interior angles. First thing to think about, alternate interior angles. So they are going to be interior angles. So angles on the inside. So there are interior angles, but there are interior angles that are on opposite sides of each other. So 1 and 4 are alternate interior angles. This angle and this angle would be alternate interior angles. So they're interior angles on opposite sides of each other. A unique thing about alternate interior angles are those two angles, when added together, will equal to 180 degrees. So if I was to add the measure of angle 1 plus the measure of angle 4, what I need to get is a degree of 180. Alternate exterior angles, on the other hand, are going to be angles on the outside, and they are in opposite corners, so they are on alternate corners. So angles on the outside and opposite corners. Same side angles, on the other hand, are going to be angles. They're same side interior angles, so they are on the inside, but they are same side interior angles instead of alternate interior angles. So because they're on the same side, they'll be on matching corners, and these are the ones that, when added together, give you 180. We'll look at these right now. Okay, so here we have a line cut by a transversal. Our transversal is R, and that transversal is a transversal because it intersects these two systems of lines. So S and Q is a system of lines, and it's intersecting that system of lines. Because of this, because it is cut by transversal, we know it creates a variety of different angles, and so we're able to identify those angles. So say I wanted to first begin by identifying all my interior angles. Interior angles are going to be all the angles on the inside. So all my interior angles, 3, 4, 5, 6. Those are all my interior angles. So 3, 4, 5, and 6. All the angles on the inside. Interior means inside. We also have exterior angles. Exterior angles are those on the outside. So 1, 2, 7, and 8. Okay. Now what about vertical angles? So vertical angles are pairs of angles that are opposite. So pairs, first of all, that are opposites of each other. So basically we're pairing angles together that are opposites of each other. 2 and 3 are angles that are opposites of each other. 1 and 4 are angles that are opposites of each other. 6 and 7 are angles that are opposite of each other. 5 and 8 are angles that are opposite of each other. So vertical angles. Next we have corresponding angles. So these are going to be those pairs of angles. They are pairs that are on matching corners. So 2 and 6, 1 and 5, right? They're on the same corner of that line. So 4 and 8, and 3 and 7. Corresponding angles. Angles on matching corners. Next thing we have are alternate interior. First thing, interior angles, but they need to be on alternate sides, so on opposite sides. Again, these are pairs of angles. So pairs of angles inside on opposite sides. So I'm looking for those on the inside. So that leaves me with only 3, 4, 5, and 6. Those are on the inside. And now I want those which are on opposite sides. So 4 and 5 are on opposite sides. And 3 and 6 are on opposite sides. And remember, they have to be on the inside. They have to be interior angles. So we are left with 3, 4, 5, and 6. And then we're pairing those. Next thing we have are alternate exterior. These are going to be pairs of angles, but these pairs of angles are going to be on the outside and they're going to be on opposite sides. So we're limited to those on the outside, 1, 2, 7, and 8, and those on opposite sides. So 1 and 8 are on opposite sides, and 2 and 7 are on opposite sides. And then lastly, we have no, I just use that color. I use this one. Lastly, we have same side interior angles. So first thing, we need them to be interior angles, and these are going to be pairs of angles on the inside. So we're limited to the interior. So we're limited to 3, 4, 5, and 6. But these are going to be angles on the same side, not on opposite sides. So 4 and 6 are interior angles on the same side, and 3 and 4 are interior angles on the same side, or 3 and 5. So what you'll notice is we're able to identify all these different types of angles whenever we have a transversal which intersects a system of lines. So 2 lines like this. Okay, any questions? And now we're going to look at the relationship between these. Give me 1 second. Weird, okay. Okay, so what is the relationship between these? Well, we have relationships which go with some of our angles. So for example, corresponding angles. When angles are corresponding angles, again, corresponding angles are angles on the same matching corners. So matching corners. So basically, we have these 2 lines, our system of lines. We have our transversal, which intersects those systems of lines. So basically, the corresponding angles will be corresponding in relation to where they are on those lines. So like 1 and 5 are corresponding angles because they're on the same location of whatever line they are. So A is on the far left. Sorry, 1 is on the far left of line A, and 5 is on the far left of line B, so they are matching corners. So basically, we're looking for the corresponding location in relation to the lines that they are part of, or the angles they are part of, the lines. So we have all these different corresponding angles, and what you need to know is that all corresponding angles are congruent. So pairs of corresponding angles are congruent. So say that this was equal to 60, then this would also be equal to 60. Say that 2 was equal to 120, well then its corresponding pair, 6, would also be equal to 120. So corresponding angles are congruent. The pairs are congruent to each other. Okay, any questions about this? So pairs of corresponding angles are congruent to each other. We also have alternate exterior angles. Alternate exterior angles, again, are going to be exterior angles. So we're going to do away with all of our interior angles. They're going to be exterior angles that are on alternate sides, so on opposite sides. More specifically, these are going to be on opposite sides of the transversal. So we're looking at this in relation to that line right there. So for example, 1 and 8 are on opposite sides of the transversal. 1 is on the left side of the transversal and the other is on the right side. 2 and 7 would also be a pair of alternate exterior angles because 1 is on the right side and 1 is on the left side of that transversal. What you need to know about these is those are also congruent. So if 1 is equal to 70, then 8 would also be equal to 70. If 2 is equal to 110, 7 would also be equal to 110. So those are congruent. The pairs of alternate exterior angles are congruent to each other. Okay. What about alternate interior angles? Well, remember, alternate interior angles need to be on the interior. So do away with these. On the inside of those system of lines, this is the transversal. And I know this is a transversal because the direction is different. That's an easy way to point out. All of these are going this way, and the transversal goes in the opposite direction. So that's my transversal. So I have my interior angles 3, 5, 4, and 6. And then same thing, you want those interior angles to be on opposite sides of the transversal. So 1 on the left, 1 on the right, 1 on the left, 1 on the right. So 3 and 6 are pairs of alternate interior angles, and 4 and 5 are pairs of alternate interior angles. Well, these are also going to be congruent to each other. So if this is equal to 80, then this is also equal to 80. 5 is also equal to 80. If 3 is equal to 100, then 6 is also going to be equal to 100. So pairs of alternate interior angles are also congruent. Lastly, we have a relationship between same side interior angles. Remember that same side interior angles, first thing, they need to be on the interior. So on the inside, this is my transversal, again, because it's going the opposite direction. That's an easy way to point that out. These are both going downward. So I have all my interior angles, but same side interior angles on this instance, or in all instances, are going to be on the same side of the transversal. So that's my transversal. Then my same side interior angle pairs are going to be 4 and 6. They have to be on the same side. And 3 and 5. Well, what this is telling me is that if I add those together, I need to get 180 degrees. So same side interior angles must equal to 180 degrees. So if the measure of angle 4 was 70, then I can find the measure of angle 6. 70 plus the measure of angle 6 equal to 180 divided by 70 divided by 70. The measure of angle 6 is 110. So same side interior angles are supplementary. Supplementary meaning they equal to 180 degrees. Okay. Any questions about these different relationships? Questions? And then given these different relationships, we can actually solve for a lot of great things. So say here, we are asked to apply the angle relationships here. It says to analyze the drawing using the information given about the angle measures to find the other measures. Well, this tells me that angle 11 and the angle which is equal to 100 degrees are vertical angles. Well, vertical angles we know are congruent to each other. So that would equal to 180 degrees. So now I want to identify all my missing angle measures. Well, what I can identify here is that I have pairs of supplementary angles. Remember, the supplementary angles are two angles that form a straight line. And these angles, because they form a straight line, are equal to 180 degrees. Well, as I can see here, I have two angles which form a straight line, and this one is equal to 100 degrees. So I can find for my missing angle by taking 100 degrees, 80. So that means that the measure of 9 is 80. Well, the measure angle 9 has another vertical angle pair, 12, and so that will also be equal to 80 degrees. Okay, what other relationships can I identify here? Well, I can identify my interior angles. In fact, I can identify alternate interior angles. Remember that alternate interior angles are congruent to each other. 12 and 13 are alternate interior angles, so this would be 80. And 11 and 14 are alternate interior angles, so this would be equal to 100 because alternate interior angles are congruent. So basically, we're using this relationship to solve for all of our different missing angles. So I'll make this easier for us to see real quick. So we've solved for all these different angles so far. 80, 100, 80, 80, 100. Okay. Now let's look at, what about corresponding angles? Do we have any corresponding angles? Yes, we do. This angle and this angle are corresponding, which means they are congruent. This angle and this angle are also corresponding, which means they are congruent. And so what you identify is that we can use all of our different relationships between our angles to solve for all these missing angle measures. And so what we were able to do is solve for all those different angle measures using our different relationships. We can't find these angle measures just because we're not given information about one of those. If we were given the information like what the measure of angle 1 is, then we could apply the same process and solve for all those different angle measures. But in this instance, we aren't. Okay, so let's say we wanted to do the same thing here, but here we're asked to identify the measure of a specific angle. This says analyze the drawing and use the given angle measure to find other angle measures. What is the measure of angle 3? Well, here we aren't given exact values, but we are given equations. And what I can do is I can identify my transversal. And that transversal intersects a system of lines. And so because of that, I know I have my different angle relationships. More specifically, what I have here are alternate exterior angles. I have two angles on the exterior, on the outside, which are on alternate sides. What do I know about my alternate exterior angles? Alternate exterior angles are congruent to each other, so I can put those two equations congruent to each other. And solve for x. Minus 10, minus 10. Minus 2x, minus 2x. X is equal to 40. That's just what I came out when I solved it. I could also go the other way because that's a little complicated. So first I'll move this over here, just so it's easier for us to see. So plus 30, x x minus x minus x, x is equal to 40. So that's how I got x is equal to 40. Okay, so now I know it's x is equal to 40, I can plug that in. So 240 minus 30, 80 minus 30, which is 50. Okay, that means that this is also 50. So I solved for those angles. $50, $50. Now in this way, I can easily solve for the measure of angle 3 because it is a vertical angle paired to this one. And so that would also be equal to 50. But what I can also do is I can solve for all of my angles just by using all these angle relationships. So the measure of angle 3 is 50. These two form a straight line, so that gives me an is equal to 180. So this is measures angle 30. And that is 30. Sorry, I'm trying to make it as clear as possible so we're not confused. Okay. So because these are supplementary angles, this is equal to 30. It's vertical angle pairs. This one, so that is equal to 130. Same thing here. It's vertical angle pairs equal to 50. This creates a supplementary pair, so that is equal to 130 as well. And that is equal to 130. So what we're actually able to do is to identify all of the different angle measures, not just the measure of angle 3, using that relationship. Okay, so just a quick review. We learned about different types of angles that are created when we have a line cut by a transversal. More than just these, we had interior angles, exterior angles, vertical angles, corresponding angles, alternate interior angles, alternate exterior angles, and side interior angles. The relationships that we got from that are relationships regarding corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. Corresponding angles are congruent, so if we have a pair of corresponding angles, then those two measures are going to be congruent. Alternate interior angles are congruent, so a pair of alternate interior angles will be congruent. Alternate exterior angles are congruent, so a pair of alternate exterior angles are congruent. And then same side interior angles, on the other hand, are supplementary. So if I have a pair of same side interior angles, well then when I add those together, I want to get 180 degrees. I want those to equal 180 degrees because they are supplementary. Okay. Any questions about anything we looked at today? And we will review some practice problems, but basically the takeaway is whenever you have a transversal and it cuts a system of lines, we get different types of angles, and we're able to identify those different types of angles. More specifically, whenever we have pairs of these angles, corresponding angle pairs, alternate exterior angle pairs, alternate interior angle pairs, and same side interior angle pairs, what we get is different relationships between those angles. And using that information, what we can do is we can actually be given the measure of one angle and solve for the measure of all the angles, which we are doing here. Which is the unique thing about these different relationships is it allows you to start with only one measure and find all the measures because of their relationship. Okay, any questions? Okay, we'll do some practice problems very soon, but if there's no other questions, I will see you guys on Monday. Bye, guys. Bye, you too.